Hello everyone, welcome to RA tutorials on mechanics of solids. And here in this video I'm going to discuss about what do you mean by stress, strain, elastic body, plastic body and Hooke's law. So first we try to discuss about stress. To understand thoroughly about the stress, I would like to take one example that is like any arbitrary shape of a body here. So on this body I'm going to apply some force. So assume some quantity of force if I am applying. So whenever we apply a force on a body, that body may be undergoing the deformation or may not be undergoing the deformation. So whenever that means here it doesn't undergo deformation means here the body can offer some resistive force against the external force we are applying the body. It means here the resistive force can be developed by the body uh, internally, so that will be opposite to the direction of the force that we are applying externally. So this internal resistance per unit area only is called as a stress, or we can say that the internal resistance offered by the body against the deformation is only called as a stress here. So the definition is the stress is an internal resistance offered by a body against the deformation, and again that deformation is caused by the force we are applying externally over the body. And there is another form of the definition to define the stress. So that definition is given as it is the force acting per unit area of the body. Here the force means whatever the external force we are applying over the body, that force per unit area of that body is only called as here stress. And this same definition can be used for finding the magnitude of any kind of the stress that is going to take place inside the body due to the external force we are applying. So the formula simply we can write it as sigma is equal to, here the sigma is the symbol which is used for representing the stress. So sigma is equal to, we can write it as force, that is the external force we are applying, divided by area. So it means it is the force per area, that is force by area. So sigma is equal to F by A is the formula for finding the magnitude of the stress here. Okay, next we try to discuss about types of stresses here. Okay, there are different types of the stresses based upon the type of the force we are applying, we are going to apply over the body. So mainly there are three types. The first one is direct stress, and second one is indirect stress, and third one is combined stress. Here the direct stress means here uh, under direct loading conditions, whatever the type of the stress is going to take place inside the body, that stress is called as your direct stress. And indirect means these are the stresses due to the bending of the body and due to the torque going to take place in a body. And combined stress means here it is the combination of the two types of the stresses, that is direct and indirect stresses. But here in this chapter our discussion is only limited to direct stresses. So let us have a look over direct stress briefly. So next I would like to explain about direct stresses, and first I would like to give the definition for the direct stress. So what do you mean by direct stress? Here these are the stresses which occur under direct loading condition, and here direct loading means the force or load that will be acting in line with the axis of the member. So it means here whatever the stresses are developed inside the body due to the direct loading condition. So those stresses are called as here direct stresses. And what do you mean by direct loading? Whenever the load or force we are applying on the body is in line or parallel with the axis of the member, then that loading condition is called as here direct loading condition. So again here there are different types of the direct stresses are there. So what are the types of the direct stresses? So there these stresses are classified based upon again type of the force we are applying. It means it may be tensile or compressive or shear. So based upon these three types of the forces we can apply over the body. So these direct stresses are classified as tensile stress, compressive stress, and third one is shear stress. So these are the three stresses which will come under direct stress. Okay. Next, we try to define these three stresses separately by analyzing with the help of the diagram here. So first we go for tensile stress. So to understand about the tensile stress, first we try to take one simple body that is in a rectangle shape. I am taking a solid body, and on this body we are applying a tensile force. Tensile force means here the force which causes extension in the body, which stores the tensile tension inside the body. That means here we are applying the force or load which is going to cause the extension in the dimensions of the body here. That means here at the ends I have applied the two forces which is trying to elongate the body here. Here again try to observe these two forces I have represented as they are acting along the axis. That means these two forces are in line with the axis of the member. So this is only the direct loading condition. So that is why tensile stress comes under direct loading condition here, that is as direct stress. So whenever we apply this kind of the force, some extension may happen. And before that here I am taking one section. So if you consider any section inside the body, at that particular section that body can develop some internal resistance. That is only the stress already we have discussed. Whenever we apply any force over the body internally can develop some resistance. So first, whenever you consider this direction of the force opposite to that, the body can develop some resistive force. If you consider left hand side force to the right hand side direction, the body can develop some resistive force. These two forces will be equal. And again here when you consider right hand side direction, the body can develop another resistive force which is opposite to the force we are considering, which is acting right hand side direction. So this internal resistance acting per unit area only the stress here. But here these stresses, internal resistances are called, sorry, caused by the tensile force we are applying over the body. Okay, so in the same way, whatever the definition we have given for the stress, same definition we can give tensile stress. But here we need to consider the tensile force. So what is the definition we can give now? It is defined as the tensile stress can be defined as the tensile force acting per unit area. So general stress means stress acting per unit area. In the same way we have defined tensile force acting per unit area is called as a tensile stress. Next we go for compressive stress. In the same way, when we take a body, so to that body we need to apply the forces that should be compressive forces. Okay, compressive force means there may be reduction in the dimensions of the body, that is different case. But here I would like to represent the direction of the force which should be causing the compression in the body here. So along the axis the forces we have to represent which should be opposite to each other. The direction of the forces should be opposite, that means towards the center of the body, then only it will cause the compression in the body. So in this condition again the same thing happens, the body internally can develop some resistive forces according to the force we are applying over the body. So the stress means again those internal resistances against the deformation. uh, uh, Deformation is called as compressive stress. And otherwise another definition we can give for compressive stress is it is defined as the compressive force acting per unit area. In the same way we have defined the tensile stress, we can define the compressive stress also. So compressive stress can be defined as compressive force acting per unit area of that body. So that is about compressive stress. Next we go for shear stress. So shear stress, again we can take one example by considering the shear force. Here the shear force means which acts tangentially to the surface of the body. So whenever this kind of the force happens over the body, shear stress takes place. So for that we try to take one example, same solid body, and I am giving some tensile, that is sorry, tangential force, that is P, acting over the surface of the body. So due to this force, the body internally can develop some resistive force that will be also parallel to its surface but opposite to the direction of the force we are applying. So that resistive force per unit area only can be called as here shear stress, or simply stress we can call it as. But here because of the shear type of the force we are applying, that type of stress is here shear stress. And the definition again we can give, it can be defined as shear force acting per unit area. Almost all the definitions are equal, but based upon the type of the force we are considering, based upon that we are defining the stress. So that is the shear stress. And next we try to give some for we try to give a formula for finding the stresses here. The same formula we can consider, that is the basic formula, that is force by area. So any type of the stress we are considering, based upon that type of the force we need to consider. If you are considering tensile stress, we need to consider the tensile force by area. If you are considering compressive stress, we need to consider the ratio between compressive force to area. And shear stress means shear force by area. Okay, these are the symbols we can use for representing tensile stress, compressive stress, and shear stress. Sigma T is for tensile stress, sigma C is for compressive stress, and tau is for shear stress. Okay, here the P in place of P, according to the type of the stress, we need to consider the P, that is the force or load we are applying over the body. So that is about stress and its types. Next we go for discussing about strain. So what do you mean by strain here? Again, we try to take one example. So taking a small body that is of arbitrary shape as a square or rectangle I have taken. So whenever we try to apply some force, already I told you, the body can may be undergoing deformation or may not be undergoing deformation. Here I have shown that body has been deformed. That means the shape has been changed based upon the force I have applied. So the phenomenon of this deformation of the body is only called as here strain here. That means strain is the deformation produced by the force, or we can say it as strain is the deformation produced by the stress developed inside the body. Why you are considering stress means whenever we are applying the load over the body, means there is a stress is taking place. So due to that stress only the deformation is taking place, like that we can consider. So that is why the strain is the deformation produced by the stress. So like that also we can say. So the definition we can give, strain is defined as the deformation produced by the stress, or we can again in another form we can say that whenever a body is stressed, it can be said that the body is strained. The body is strained means it has deformed. That means the shape change has been taken place due to the stress developed. Again, how that stress is developed means due to the application of the force only. So finally we need to understand strain means it is related to the deformation of the body here. And again here for finding the strain, we can give another definition. That means to give the quantity to the strain, how much the strain has been taken place for the body, means we can consider another definition, that is defined as ratio between the change in dimension and original dimension. So it is related to deformation. Deformation means there is a change in the shape of the body or any object. Change in the shape means there is a change in the dimension of the body. So based upon that, another definition is given for the strain is, it is the ratio between the change in dimension and original dimension. And again observe here we are taking the ratio between two similar quantities, that is related to dimension of the body. So whenever we take the ratio between the two similar quantities, there will be no units for the element we are considering here, the strain. So the strain doesn't have any units, so no units for the strain as the ratio between the same quantities. So that we can conclude for the strain here. So that is about the strain. Simply it is related to deformation of the body due to the stresses induced inside the body. And next we try to discuss about types of strains here. So there are again different types of the strains, and these are classified based upon the same, the type of the force acting over the body, same, that may be tensile or compressive or shear force. So based upon that again we can classify as, first one is tensile strain, second one compressive strain, and third one is shear strain. And there is another special type of the strain is there, that is volumetric strain. Okay, now let us look at the definition for each and every strain. So first is tensile strain. Tensile strain again we can understand with the same example. There is a bar which is subjected with tensile force. So whenever we apply with tensile force, there is a change in the dimension happens due to the deformation of the body. Here tensile means there will be extension in the body takes place due to the force we have applied. So initially I am assuming the length of the body is as L, and after the application of the force or load P, the extension has been taken place like this, and this change in dimension, that is extension, happened to the body, I am assuming as DL, that is the change in length or increase in length. So these are the changes happened due to the tensile force we have applied, and we can find the tensile strain with the help of the definition we can give to the tensile strain. So what is the definition we can give? The strain is the tensile strain can be defined as a ratio of increase in length to original length of the bar. Okay, this is again obtained from the basic definition, that is the ratio between change in dimension to original dimension. So that is only increase in length to original length we are considering here. So finally formula we can write it as ET. ET is the symbol for representing the tensile strain. So ET is equal to, we can write it as increase in length DL divided by original length, that is L. So this is the formula we can use for finding the tensile strain. Okay, now we go for compressive strain. So compressive strain, again we can take the same example which is applied with two compressive forces, and when we apply the compressive force, change in dimension happens, like there is a decrease in dimensional value. So initially I am assuming the length as L, and after decreasing length, that change in the length again I am assuming as DL. DL is the decrement in the length has been taken place for the body after the application of compressive force. So these are the changes happened to the body due to the compressive force we have applied over the body. And now we try to give the definition, that is again same definition we can give as compressive strain can be defined as the ratio of decrease in length to original length of the bar. Okay, it is the ratio between change in length to original length. In the same way, decrease in length to original length. So the formula we can write again, EC, that is the compressive strain symbol, is equal to change in length, that is decrease in length DL divided by original length L, we can write. So this is the compressive strain formula we can give, which is again uh, decrease in the length divided by original length. Okay, that is the compressive strain. Next we try to go for shear strain. So shear strain again happens due to the shear force we apply over the body. So for that, here it is somewhat different from the tensile and compressive. So to understand thoroughly, again we try to take an example. Okay, so this is the body I am taking, a rectangular block, assume. The names I am giving as ABCD, and this ABCD block is fixed at one end, that is AD, assume. With respect to that fixed end AD, we are applying one shear force over the surface, that is BC. So whenever we apply the shear force over the surface, it will try to change its shape. That means it can undergo deformation, it can occupy new position. So for that I'm assuming after the application of the shear force P, the shape has been changed like this. Okay, that means B has changed to the new location B dash, and C has changed it to the new location as C dash. Okay, and this deformation has taken place in the form of angular deformation. So that angle I'm assuming as phi. Okay, that means here whenever the shear force takes place, the deformation takes in the form of angle. Okay, so based upon this, again we can define the shear strain as shear strain. We can give one statement for the shear strain, that strain is produced by the shear force. uh, Not like that here. Strain produced by the shear force is called as shear strain. Sorry, here I am giving the definition, that is the strain produced by the shear force. Okay, but again, how it can be measured? So how can we measure this shear strain? Means here it is measured in the form of the angle through which the body deforms. Here the deformation of the body is taking place in the form of the angle, so that is why we can measure the shear strain in the form of the angle through which the body has deformed here. So from the figure here, from the right angle triangle, if you consider A B B dash, tan phi is equal to, we can write it as B B dash by AB. Okay, so as phi is very small, the deformation will be very small. So when the phi is very small, so tan phi can be directly written as phi in radians. So that formula can become b dash by ab. Okay, this is the formula we can use for finding the shear strain, which is in the form of the angle here, because the deformation is taking place in angular form. So the angle we need to find to know the shear strain. So that is about shear strain. So these are the types of shear strain, and the last one is under types of strains, volumetric strain. Okay, it can be simply defined as it is the ratio between change in volume to the original volume. So it is defined as the ratio, sorry, it is defined as the ratio of change in volume to original volume of any object or body. Okay, that is going to undergo deformation. So the formula we can write it as EV, volumetric strain. EV is equal to change in volume by original volume. Okay, for this one also there will be no units because we are taking the ratio between the two volume quantities only. Okay, so that is about types of strains. And now we try to discuss about elastic body. What do you mean by elastic body and what do you mean by plastic body? Okay, so now look at what is the definition we can give for the elastic body. So try to read out the definition. Here the definition I have given, like, if a body regains its original shape or dimensions after the removal of the load or force that is applied on it, then the body can be called as elastic body. Okay, here after the application of the load we are saying that the body can undergo deformation. Okay, even after the deformation, if we remove the load, if the body regains its original shape, then the body can be called as your elastic body. Okay, so that is about elastic body. Next, plastic body. What do you mean by plastic body? Again, try to read the definition here. If a body left with its deformed shape after the removal of the load or force, then the body is called as plastic body. So plastic body is opposite to the elastic body. So again, we are saying that after the application of the force, the body can undergo deformation. If that deformation is permanent, even after the removal of the load also, then that type of body can be called as a plastic body. If the deformation disappears after the removal of the load, the body can be called as elastic body. If the deformation exists even after the removal of the load, then the body can be called as a plastic body. Okay, that is about elastic body and plastic body. Okay, next we go for elastic limit and Hooke's law. What do you mean by elastic limit again? So elastic limit. Okay, here again go through the definition. There is always a limiting force up to which total deformation will disappear after the removal of the load. That limiting force is only called as elastic limit. Okay, so up to certain limit of the force that we are applying on the body can regain its original shape after the removal of that limiting force. Okay, that limiting force only called as your elastic limit. So within that elastic limit, after the removal of the load, the body regains its original shape. That means the body can act as an elastic body. So beyond that value, the body becomes plastic. Okay, that limiting position only here is called as elastic limit. Okay, next we go for Hooke's law. What is Hooke's law here? So with the help of elastic limit, Hooke's law given one statement. So what is that statement? Means here Robert Hooke experimentally proved that within the elastic limit, the stress is directly varies with strain. The statement he has given as within the elastic limit, the stress directly varies with strain. That means stress is directly proportional to strain within the elastic limit. Okay, so stress is directly varies with strain means stress is directly proportional to strain. So for making equal, we have to take one constant of proportionality. So stress is equal to some constant value into strain, and again stress by strain can be written as some constant. So this constant is only called as your modulus of elasticity. So modulus of elasticity means it is the ratio between the stress and strain which is obtained from the Hooke's law. What is Hooke's law? Within the elastic limit, the stress is directly proportional to strain. Okay, that is about elastic limit and Hooke's law. And I hope you understood about the basic terms related to the mechanics of solids, that is stress, strain, elastic, plastic bodies, elastic limit, and Hooke's law. If you still have any doubts, please feel free to give a comment to my video so that I will try to clarify your doubts. And once again, thanks for watching my video. Thank you all.